Hello everyone, welcome to this session. Today's class will be talking about JEE Advanced pattern question. I believe that you would have already given JEE main examination and will be ready for JEE Advanced examination that will be held in the month of May. Now let me tell you, in JEE Advanced the questions are asked that is single choice, more than one option correct, assertion reason and integer type, and even matrix match type also question you get. Now today's class will be talking about actually what kind of questions do come in your JEE Advanced examination. First of all, let me tell you the level of questions are very high. In today's class, I'll be talking about the level of question that is kept at moderate level, and some questions are really tough, some questions are tricky. Let's talk about some good 5 questions that are asked in previous year examinations, and such pattern of questions can be repeated in your JEE Advanced questions. Let's go ahead, and I believe that your practices and your preparation is quite good. Let's go ahead. The first question, x and y displacement of a particle are given as x equal to a sine omega t and y equals to a sine 2 omega t. Its trajectory will look like, we have given 4 curves, A, B, C, D. You would have learned about motion in a plane. You would have learned about the path of a parabolic projectile motion. Now, in today's question, what I'm seeing here, that we are provided with x variable, y variable, how they are related, and then we have to sort out which curve actually suits to the given equation. Let's go ahead, let me write here x equal to a sine omega t. So let me show here, if x equal to a sine omega t, this is what that has been provided to us. From here we can write sine omega t is equal to x by a. Quite obvious. Cos omega t, we know that that is equal to 1 minus sine square omega t. So we can write this as 1 minus sine square omega t. Let us write down this as 1 minus sine square omega t. So x square by a square. Quite clear to us, 1 minus x square by a square. We have written about what will be the value of cos omega t. Why we have done this, that you will understand when you see this y equals to a sine 2 omega t. Now you see here y equals to a sine 2 omega t. If I write it here, y equals to a sine 2 omega t. We know that sine 2 theta is equal to 2 sine theta cos theta. So we are going to apply that 2a sine omega t multiplied with cos omega t. Quite obvious, we can write it. Now see here, a sine omega t, this is equal to x. You can see here a sine omega t is equal to x, and cos omega t can be written in this way. So I am going to write this as 2x and cos omega t, that can be written as 1 minus x square by a square. So we got this 2x under root 1 minus x square by a square. So we are going to obtain this as 2x by a under root of a square minus x square. Quite obvious, we can actually show that this will be, y will be related with x in this way. This is the relation between y and x. Now we got the equation of the actually motion of the particle. Now see, y and x is written in this way. If we see the curve 1, 2, 3, 4. First of all, check here if x equal to 0. I would like to see if x equal to 0, y will be equal to 0. So let me write here, if x is equal to 0, we will be getting y will be equal to 0. Let me write down that as y equals to 0. Next thing, one more thing you check, if x equal to a, y will be again equal to 0. So again I am writing here, if x is equal to a, y will be equal to 0. 2 points we can easily make out, because x equal to a, this term will be 0, automatically we are going to get y as 0. X is 0, then y is 0, it is not matching here, it is not matching here, it is matching at the option number C, x is 0, y is 0. Option number D, x is 0, y is 0, so both C and D are matching, but we can eliminate A and B. Now let's check with C and D option. It's given that when x equal to A, y equals to 0, that we have seen already. X equal to A, this point is x equal to A, then x equal to A you can see here, then y will be equal to 0. You can see here, x equal to A, y will be equal to 0. We are not getting any such point in this curve, that is curve D. So the right answer that we'll be having, that is the option C, will be the right answer. When x equal to a, y equal to 0, we are seeing that at any point for x we are getting y as 0. and we can see that the curve is symmetrical about the y-axis. That's why it's symmetrical about y-axis. So option number C truly matches with the given option, with the given answer. So the right answer is option number C in this question. So let's go ahead with the next question. Before that, just let me clear the board for you all. Yeah, next one. The next question of the class, we have question number 2. A particle strikes a horizontal surface or horizontal frictionless floor with a speed u at an angle theta with the vertical and rebounds with a speed v at an angle phi. It's given that it strikes with a speed u, it's actually speed, don't get confused, it's actually speed u at an angle theta with the vertical and rebounds with a speed v at an angle phi with the vertical. The coefficient of restitution between the particle and the floor is E. The angle phi is equal to A theta, B tan inverse E tan theta, C tan inverse 1 by E tan theta, and D 1 plus E theta. First of all, let me tell you the scenario. Let me show you the scenario, what is actually happening in this case. Look here. This is the horizontal floor that we can observe. The particle goes, strikes. Let us draw the normal. It strikes at some angle that has been provided to us. This angle, you see here, it strikes the floor at an angle theta with the vertical. So let me mark here, this angle is theta. It rebounds with a different angle. Let me show that it rebounds at an angle phi with the vertical. This is what has been given. Moves with speed u, then again finally reflects with speed v. See, we have marked its speed u, initial speed, angle theta with the vertical, then again rebounds with speed v at an angle phi with the vertical. I believe that you will be remembering about the coefficient of restitution thing. You see, that is equal to coefficient of restitution, you must be remembering, that is equal to velocity of separation divided by velocity of approach. Quite clear to us. We know that this is the formula for E. From here now, see velocity of separation, velocity of approach. If we talk about the vertical velocity, the initial vertical velocity will be equal to u cos theta and final vertical velocity will be equal to v cos phi. So we can write E is equal to v cos phi divided by u cos theta. This is what we can actually write it. Next thing you see, we need to find out the angle phi is equal to. We need to find out what is the value of angle phi. So what you do, we have already shown how E is actually related with the velocity of separation, velocity of approach. I have velocity of separation, that is actually with what velocity it will rebound, what is the vertical component of the velocity, and velocity of approach with what velocity along the vertical direction it is approaching towards the horizontal floor. Now we have written down this relation, so we can write V is equal to we need to write completely V cos phi is equal to EU cos theta. That's quite simple, quite obvious, we can write it that. So what you do, you take note till here. I'll start from the other end of the board. Okay, what I wanted to show you all from this figure, you see here the horizontal velocity will be no change. There will be no change in the horizontal velocity. So initial horizontal velocity will be equal to final horizontal velocity. So we can write u sin theta is equal to v sin phi, or we can write v sin phi is equal to u sin theta. This is also we can show. Equation number 1, equation number 2 we have got. Now you see here v, we can write v is equal to u sin theta divided by sin phi. This is we can show straight away. So we got this v, we have got how it is related to u. Now you see here, from here cos phi is equal to EU cos theta by v. So from equation number 1, from 1 we have cos phi is equal to EU cos theta by v, EU cos theta by v. Substitute the value of v from this equation, you can put it here, you will be obtaining a relation that will look something like this. Cos phi is equal to EU cos theta by V. EU cos theta by V. V is actually U sin theta by sin phi. U sin theta by sin phi. From here we can see that U and U will be cancelled out. We will be getting a relation sin phi will move up. So we can write this as cos phi is equal to E cos theta by sin theta, cos theta by sin theta, and sin phi will be multiplied here. If we simplify this relation, we take sin theta here and divide by cos theta, we will be having tan theta, and here if we divide by cos phi, we will be having E, and here we will be having tan phi. So tan phi from this relation, you see tan phi will be equal to 1 by E tan theta. We need to find out how phi is related with theta. So quite obvious, we can write phi is equal to tan inverse 1 by E tan theta. So tan phi equals tan inverse 1 by E tan theta. Let us check the option that we have. You can see option number C, that's matching with the right answer. Tan inverse 1 by E tan theta, that is the value of phi. It's a good question. People actually get confused how to actually use this term that we have here, coefficient of restitution. Remember that coefficient of restitution is just the ratio of velocity of separation to velocity of approach, and then only you can solve such kind of question. So I believe that this two questions that we have done, this would be of great help to you all and would have understood how to approach with such questions that we have. Next question of the class that we will be discussing, that is question number 3. Question number 3 and 4, it is more than one option correct. In your JEE examination, more than one option correct also question comes, in which let's say 2 options may be correct, 3 options may be correct. Let us say in a question if 3 options are correct, if you mark all the 3 correct, you will get maximum marks. And if you mark only 2 options as the correct option, you will get +1 for 1, +1 for 1, plus only 2 marks. So you lose 2 marks for your not answering one option, the third option as the right answer. So in this way you have to mark all the options correct, or even if you are not able to arrive at all the options, do mark as many options you think are correct. Let's go to the question. In the circuit shown in the figure, we have a figure here. There are 2 parallel plate capacitors. So we can see capacitor C1, capacitor C2, 2 parallel plate capacitors. Each of capacitance C, the switch S1 is pressed first to fully charge the capacitor C1 and then released. The switch S2 is then pressed to charge the capacitor C2. After some time, S2 is released and then S3 is pressed. After some time, now we have to, as per the given information, we have to check which option is right. Option number A, the charge on the upper plate of C1 is 2 CV0. The charge on the upper plate of C1 is CV0. The charge on the upper plate of C1 is 0. The charge on the upper plate of C2 is minus CV0. So in the options, we have to check what are the charges on the upper plate of C1 and C2. Now first line you read, you will get that only S1 is connected. If I show you the circuit, only S1 is connected, that means capacitor C1 will be connected to the battery of EMF 2V0. And rest of the part will be not connected to the system, that is C2, and this cell will not be connected. That is C1 will be isolated from rest part of the system. Let me show you the diagram, how will it look like. This is the diagram of the connection of the capacitor C1. So this is capacitor C1, this is cell of EMF 2V0. Switch S1 is closed. So let me mark here switch S1 which is closed. Now easily we can identify that the charge on the upper plate that is appearing here, if I mark it as Q1, that will be 2CV0. Why that? Because Q is equal to capacitance into the EMF of the cell, 2V0 into C1, and C1 is equal to C. So I am marked here 2CV0. That's quite simple. Now you read the second line, it says that it is released. The switch S1 is pressed and then released. So what will happen? The charge on the capacitor C1 will remain 2CV0. Now you see what we are going to do. The switch S2 is then pressed to charge the capacitor C2. S2 you press. That means C1 and C2 will be in connection. And we know what to do when capacitors are connected in this way. When switch S2 is pressed, C1 will not be connected to the cell of EMF 2V0. This is C1 is equal to C. This is C2 is equal to C.
So in total, you see what we are having. We are having here 2 CV0, and we are having, initially it was uncharged. Now you see, when a charged capacitor is connected to another capacitor, the charges distribute in the ratio of their capacitance. It's very easy for us to identify that since both the capacitor are of same capacitance, equal charges will appear on each of the capacitor. So here, if I mark, the charge appearing will be half of initial, because total charge is 2 CV0. So here Q1 dash I am marking, it will be CV0, and here if I write the starting charge as Q2, that will be CV0. This will be the first case. I have marked the charge on the upper plates of the capacitor. That's what, here it will be CV0, and here you will be having CV0. This will be how the charges will distribute among C1 and C2 as per the shown diagram. Now read the third statement. After some time, S2 is released. Now S2 is also released. This part is released. That means C1 will no more be in connection. And S3 is pressed. Then S3 is pressed. Now S3 is pressed, so C2 will be connected to this cell. So if I draw a new diagram showing you the connection between C2 and the new cell that is having a negative polarity at the upper end and positive polarity at the lower end. So how will it look like if I draw the new diagram? This is C2, the negative polarity at the upper end and positive polarity at the lower end as per the diagram. This is C2 is equal to C, and this is having a EMF and EMF of V0. Just I want to clarify the diagram with you all. Do observe the negative polarity at the upper end and positive polarity is at the lower end. Now, when a capacitor is connected with a new cell, it doesn't matter whatever charges do initially exist on the plates of capacitor, the capacitor will acquire the charge based upon the new cell which you have connected. So it doesn't matter whether the charge on the capacitor initially was CV0, that has got no role to play. The charge appearing on the capacitor will depend upon the new cell connected. So let's switch to the diagram. So initially, although it was having CV0, the upper plate was having CV0, but that will be no more CV0. The charge appearing on these plates will depend upon the final battery connected. That is, you see negative polarity is here. So this plate will be having plus CV0 and this plate will be having minus CV0. So for upper plate, if I write on upper plate of C2, because for all the charges we are required, upper plate of C2 is equal to C, we are having the charge that is equal to upper plate of C2 is having a charge minus CV0. I hope that this point is clear to you. As you see, minus CV0. If you are thinking that, initial charge was CV0 here, where the charge has gone, actually the charge will move through the battery and the net charge will appear on this upper plate of capacitor only due to the new cell that is connected. So we need to identify what are the charges existing on the upper plate of capacitor. You see here, on the upper plate of capacitor of C2, we are having minus CV0. And from here, the final charge on the upper plate of C1 is only CV0. You identify. So upper plate of C1, if we write, upper plate of C1 is CV0, charge on upper plate of C1. To make it complete, charge on upper plate of C1 is CV0 and charge on upper plate of C2 is minus CV0. Let's read the options. A, the charge on upper plate of C1 is 2 CV0. No, that was only when S1 is pressed, but finally that is not 2 CV0. This is incorrect. B, the charge on the upper plate of C1 is CV0. Yes, this is the right answer. Option number B is the right answer. C, the charge on the upper plate of C1 is 0. No. The charge on the upper plate of C2 is minus CV0, that just now we identified. So B and D are the right options for this question. I am marking here B and D. Now in your examination, if you tick both the options correct, you will get plus 4 marks. If you tick only B, then you will be getting plus 1 mark, no negative mark if you have chosen the correct option. And if you mark any of the wrong option, although you have marked one option as correct and one option as wrong, you will lose marks, you will get negative mark for that. So do mark the right option, as many right options you arrive in your answer. So this was all about question number 3. Now we'll start with next question. Before that, let me just rub the board for you all. Question number 4. A horizontal stretched string fixed at two ends is vibrating in its fifth harmonic
according to the equation yxt 0.01 sine 62.8 per meter x cos 628 per second t. Assuming pi equals 3.14, we know that pi equals 3.14. The correct statement can be only 1 or can be r, it can be more than 1. The number of nodes is 5, the length of the string is 0.25. The maximum displacement of the midpoint of this string from its equivalent position is 0.01 meter. Let me rub this part that we have done. The fundamental frequency is 100 hertz. We got this. Now it says that string is vibrating and it's vibrating in the fifth harmonic. It's a case of standing wave. It's a case of standing wave. If I draw the string, how will it look like? This will be the string. It's a case of fifth harmonic. So I'm showing you the number of nodes and antinodes that you have to draw. You have to draw 5 such curves that will be required. So 1, 2, 3, 4, 5. Yes, now it's okay. Let me just complete this. So we got this, and it is in standing wave. So I need to complete it. It's a case of standing wave. Now, if you see the equation y equals to 0.01 sine 62.8 x cos 628 per second t, let me write down that equation. Y equals to 0.01 sine 62.8 x cos 628 t. I believe that you must be remembering about the standing wave general equation. The general equation is given as y equals to 2a sine kx cos omega t. This is the general equation that I have written. Sine y equals 2a sine kx cos omega t. K is the wave number, omega is the angular frequency. Can we write down this equation in a different way? First of all, let us write down the equation in a different way. How will it look like? Y is equal to 0.01 sine, we have 62.8. Can we write that as 20 pi x? Just check, we can write that as 20 pi x, not a problem. 62.8 can be written as 20 pi. Next we can write cos 628 we have, that can be written as 200 pi t. This we can write in the simple way. That means k we are obtaining, if we compare, k will be 20 pi. K is equal to 20 pi from here, and we know that k is equal to 2 pi by lambda. So we can write this as 2 pi by lambda. Compare this, we will be getting the value of lambda. Lambda will come out to be 1 by 10 meter. Lambda is equal to 1 by 10 meter. We got this. And omega you can easily find out, it will be 200 pi. So frequency we know it's omega by 2 pi. See what it will come out? It will come out to be 200 pi divided by 2 pi. It comes out to be 100 per second. We got the value of frequency, we got the value of lambda. Now let's see what more we can actually find out from this. This is the case of fifth harmonic. The number of notes we need to count down. Count 1, 2, 3, 4, 5, 6. 6 notes I'll mark here. Node 1, N1, node 2, N2, node 3, N3, node 4, N4, then we have node 5, and last but not the least, that is node 6. 6 nodes in total. The first option, the number of nodes is 5. No, it's only 6. The length of the string is 0.25. We need to find out what is the length of string. Let's comment on the length of the string. Now, if length of the string, that will be equal to, now this length is lambda by 2. You must remember this length is lambda by 2. So lambda by 2 multiplied by 5 we can easily write down. Lambda is actually equal to 1 by 10 meter. We can write 0.1 by 1 by 10 meter means 0.1. So 0.1 by 2 multiplied by 5. So we will be having this as 5 by 2 as 2.5. 2.5 into 0.1, 0.25. 0.25 meter. So option number B is correct. Length of the string is 0.25 meter. That is correct. C. The maximum displacement of the midpoint of the string from its equilibrium position is 0.01 meter. This thing is the amplitude, no doubt. This will be 0.01 meter as per the given information that we can easily make out. But you see, midpoint will be this. If you check the midpoint, if we talk about midpoint, where it will lie? It will lie in the center, and there are 5 in total. There are 5 columns you can see, 5 wave part. So this part will be the midpoint. The maximum displacement of the midpoint, easily we can see that is equal to the amplitude, and that is equal to 0.01 meter. So yes, maximum displacement of the midpoint of the string from its equilibrium position is 0.01 meter. Yes. D, the fundamental frequency is 100 hertz. We found that the frequency is 100 hertz. So the 1, B, C, D are the correct options. So let me write down for this one B, C, D. All the 3 options will be the correct options for this question. Let me just clear the board for you all, and we'll proceed with the next question. I believe that you have understood how to do such kind of question. People actually leave this chapter, that is the waves. If you are thorough with the concept of waves, if you know how this harmonic diagram you make, what is first harmonic, what is second harmonics in different cases, when the string is fixed at one end, when the string is fixed at both the end, and for columns, when the air column you also take, in that case also you have to actually frame the equations for standing waves. Basic concepts, but much useful. If you know them, you can easily solve such questions that will come in your examination. Let's go ahead with the next one. Before that, some part are left. Okay, let's go ahead. I believe that you are enjoying and you are finding it quite helpful for you all in your preparation. I will not take more time. Let's switch to the next question. Integer type. We have now question integer type. A metal is heated in a furnace where a sensor is kept above the metal surface to read the power radiated by the metal. The sensor has a scale that displays log base 2 P by P naught, where P naught is a constant and P is the power, when the metal surface is at a temperature of 487 degrees Celsius. The sensor shows a value 1. So we know that when this metal surface is at a temperature of 487 degrees Celsius, the sensor shows a value 1. Assume that the emissivity of the metal surface remains constant. What is the value displayed by the sensor when the temperature of the metal surface is raised to 2767 degrees Celsius? First of all, let me write down both the temperature in terms of Kelvin, because calculations cannot be done until you know the temperature in terms of Kelvin. 487 degrees Celsius will be equal to 487 plus 273 in terms of Kelvin. You can easily solve it out with 760 Kelvin. 3 plus 7, 10, 0. Then we will be having 1, 9 plus 7, 16. And 1 plus 4, 5 plus 2, 7. 760 Kelvin. Then we have 2767 degrees Celsius converted into kelvins, because somewhere we will be finding its help. See what we will get for this. You get 7 plus 3, 10, 0, 1 plus 6, 7 plus 7, 14. Again 1, 1 plus 7, 8, 8 plus 2, 10, 0, 1, 3040 Kelvin. Quite obvious, you got both the temperatures. I believe that you must be remembering the power formula from the Stephen-Boltzmann rule. You see here, P equals to E sigma A T to the power 4. E is the emissivity, sigma is the Stephen-Boltzmann constant, A is the area, T is the standard temperature expressed in kelvins that we need to know. Now it says that when this metal surface is at a temperature of 487 degrees Celsius, the sensor shows a value 1. Now for temperature P1 I am going to keep as E sigma A T to the power 4, that means 760 to the power 4. we got this first power. It says the sensor shows a value 1. The sensor actually depicts what? Log base 2, and you see here it's given that you can read in the question, it's given P by P naught. P naught is constant. P by P naught, that is equal to 1. From here we can easily make out that P by P naught will be equal to, I am writing this P1. So P1 by P naught will be equal to 2, or P naught is equal to P1 by 2. P1 was what? E sigma A t to the power 4, that was 760 to the power 4 divided by 2. So we got this. For the value of 487 degrees Celsius, we have kept that power radiated is given as P1. So we got the value of P naught in terms of P1 in terms of this Stephen-Boltzmann rule. Next thing you see here, what is the value displayed by the sensor when the temperature of the metal surface is raised to 2767 degrees Celsius? When the temperature is this, the power radiated will be what? Can we write down that? When the temperature is 3040 Kelvin, so power will be P2 E sigma A 3040 to the power 4. What will be the value of the sensor? That gives us log base 2 P2 by P naught. We know this. Now substitute the value log base 2. P2 will be this E sigma A 3040 power 4 not a problem, and then we have P naught, that is P1 by 2 E sigma A 760 power 4 and divided by 2. This entire term was divided by 2. Let us enclose this in a bracket. This is required. The terms that will be cancelled out easily, E sigma A cancelled out. 760 will go 4 times for 3040. 3040 by 760 is 4 times. You are getting 4 to the power 4 multiplied by 2. This you will get log base 2 4 to the power 4 multiplied by 2. From here, if 4 to the power 4, you can write that as 2 to the power 8, and multiply by 2, you will get 2 to the power 9. So log base 2 2 to the power 9. You will get this as 9. So in your examination, the bubble that you have to circle, that will be actually for integer 9. We did this question based upon radiation. Question can come on this chapter, that is the heat and temperature chapter. We have learned the concept of radiation. From there also question can be asked. Now here I have taken the question based upon waves and radiation, motion in a plane, and then again magnetism, electricity and magnetism, electrostatics we have talked about. Now what I want from you all, in these 5 questions, we have actually taken a crisp of the syllabus, but the syllabus is quite big. You should know every part of the syllabus. Now see, let me tell you, don't limit yourself, don't try to excuse yourself that let's leave some chapter. Try to cover entire chapter. Basic questions would be asked, but application would be quite in depth. If you know how to apply, if you have practiced more questions, you can certainly answer them. So I wish you all the very best for your JEE Advanced examination that will be held in the next month, and I wish that you score more in your both mains and advanced examination. Wish you all the very best and prepare well.